We divide both sides by 81 to get that x is equal to 12,345. You'll be able to solve almost any question from any chapter that was covered in the series. Hello and welcome to our very first and most basic tutorial on pharmaceutical calculations. This series of tutorials are based on the 13th edition of the textbook Pharmaceutical Calculations by Howard C. Ansel, one of the most popular textbooks on Pharm Calc out there. Today, we'll be looking at the International System of Units, which is the chapter 2 of this textbook. The bulk of what we'll be dealing with on this topic may look very simple, but please stick to the end of the video, because if you miss out on any part of this, it will be more difficult to grab the advanced topics like radiopharmaceuticals, isotonicity, milliequivalents, and others. The purpose of doing this tutorial series is such that when you are done with the entire series, you'll be able to solve almost any question from any chapter that was covered in the series. Trust me, everything will be simplified and all the necessary topics will be covered using School of Pharmacy Agulu as a reference. So, are you ready? Are you ready? Are you ready? Are you ready?
Yes, I am. I am.
Good. Let's get started. The International System of Units is a globally recognized system of units for taking measurements like weight, mass, etc. It was formerly known as a metric system. With the introduction of the SI units, certain measuring units like gallons, feet, and pounds were replaced by units like liters, meters, and grams. The process through which this change occurred is referred to as metrification or metric transition. There are certain words that are attached to these SI units that help to make documentation of measurements much easier. These words are called prefixes, and each prefix has a value that it represents. There's a reference table I'll show you later. For example, it is much better to record a value of 12,000 grams as 12 kilograms. More so, a value like 0.002 meters can best be recorded as 2 millimeters. In the examples given, the words kilo and milli serve as prefixes for SI units, grams, and meters. Kilo represents 1000, hence 12 kilograms actually means 12 times 1000 times grams, which is equal to 12,000 grams. Similarly, milli represents 1 all over 1000, hence 2 millimeters means 2 times 1 all over 1000 times meters, which is equal to 0.002 millimeters. Before we jump right into calculations and solving exercises, let us take a brief look at a little more theory. It is going to help on the long run, trust me.
Bro, can we just go straight and solve exercises, comrade? Or you need some violence first?
The numerical portion of this measure, which is 12, is known as the denominator number, while the unit portion, which is kilograms, is known as the denomination. Now, that unit portion of kilograms can be shortened to kg. This short form is not called an abbreviation. Instead, it is best described as a symbol. Here is a reference table for the various types of prefixes and the values they represent. You do not need to know all of them. Over time, you will get used to the most common ones like nano, micro, milli, centi, kilo, and mega while solving exercises. Apart from the SI unit system, there are other systems like the avoidupoi that measure weights in pounds and the apothecaries. The table shown now tells us the relationship between some of these older units and the SI units. This will help us in calculations that involve the interconversion of these units. Now, the fun part. Let us solve some exercises.
Yes, we will start from case in point.
No, case in point is usually the most challenging exercise in every chapter. We will start by solving some exercises of varying difficulties first to build understanding. Then we will conclude by solving the case in point.
Is that so?
Yes, it's so.
Is that why you're shouting?
Yes, that's why. Get out of my screen. Sorry about that, guys. From the textbook practice problems, we will solve questions 1, 6, 10, 26, 46, after which we will conclude with the case in points. I have tried to spread out the questions and pick ones that appear to be more confusing. However, if you are unable to solve specific questions, please let me know in the comments box and I'll try to attend to it there. Also, check the video description, end screen, or comments box for links to other videos where I have solved even more examples on this topic and other topics. So, let's get into question 1. Question 1 says add 0.5 kg, 50 mg and 2.5 dg. Reduce the results to grams. For this question, we simply have to convert all the given units to grams first, then add all of them. Let us do well to remember that the symbol for decigram is dg and that of decagram is dag. Now, there are two ways to do the conversion, but I'll show you the one that I believe will be faster and easier on the long run. The first step is to look at our reference table to determine the values of kilo, milli and deci, because those are the prefixes available in the question we are trying to solve. From the table, we can see that kilo represents 1000, milli represents 10 raised to the power of minus 3, which is the same thing as 1 all over 1000. I know it's 1 all over 1000 because there should be 3 zeros as the value says 10 to minus 3. And finally, deci represents 10 raised to the power of minus 1, which is the same thing as 1 all over 10. Same logic, it is 10 because the value says 10 to raised to the power minus 1, which means 1 0. Now, to use these values in doing the conversion, it is always good to start with a value of 1, then include the number you want to convert, and then cross multiply it to get your answer. Here is how it's done. To convert 0.5 kilograms to grams, we start by saying that 1 kilogram is equal to 1 times kilo times grams. Since we know that kilo represents 1000 from the table, we can say that 1 kilogram is equal to 1 times 1000 times grams. Therefore, we have the relationship 1 kilogram is equal to 1000 grams. Now, 0.5 kilograms will be equal to how many grams? Let's call that x. Now, when we cross multiply, we have that 1 times x is equal to 0.5 times 1000. Hence, s is equal to 500 grams. Now we know that 0.5 kg is the same as 500 grams. Let us do a similar conversion for the next value, which is 50 milligram. From the table, 1 milligram is equal to 1 times 10 raised to the power of minus 3 times grams, which is the same as 1 times 1 all over 1000 times grams, which is also the same as 0.001 gram. Hence, we have this relationship. 1 milligram is equal to 0.001 gram. Therefore, 50 milligrams will be equal to how many grams? Let's call that x. Now, we cross multiply to have that 1 times x is equal to 50 times 0.001 gram. Hence, x is equal to 0.05 grams. Now, we know that 50 milligram is the same as 0.05 grams. Finally, let's convert the last value, which is 2.5 decigram. 1 decigram is equal to 1 times 10 raised to the power of minus 1 times grams. Hence, 1 decigram is equal to 0.1 gram. Now, 2.5 decigrams will be equal to x grams. Let us cross multiply. 1 times x is equal to 2.5 times 0.1. Therefore, 10 decigrams is equal to 0.25 grams. Now, let us add up all the answers we got in grams to get the total as requested by the question. 500 grams plus 0.05 grams plus 0.25 grams is equal to 500.3 grams, which is the final answer. In subsequent examples, I will skip some of the steps I already explained in example 1 in order to save time and not bore you. Let us proceed to the next question on our list, question 6. A low-strength children's/adults chewable aspirin tablet contains 81 mg of aspirin per tablet. How many tablets may be prepared from 1 kg of aspirin? From the question, 1 tablet is equal to 81 mg. Therefore, to know how many tablets can be prepared from 1 kg, we simply need to find out how many 81 mg of the drug are inside that 1 kg. Let us convert 1 kg to milligrams, then divide it by 81 mg to know what our final answer would be. To make things clearer, we will first convert 1 kg to grams, then convert our answer in grams to milligrams. As we already know, 1 kg is equal to 1000 grams. Now, to convert this to milligrams, we know that 1 milligram is equal to 0.001 grams. Hence, x milligram will be equal to 1000 grams. Notice how we have carefully placed grams under grams and milligrams under milligrams before cross-multiplying. Always ensure that values are placed on the correct sides to avoid getting wrong answers. On cross-multiplying, we have that x times 0.001 is equal to 1 times 1000. 0.001x is equal to 1000. To find x, we divide both sides by 0.001 to have that x is equal to 1000 over 0.001, which means that x is equal to 1 million milligrams. What this means is that 1 kilogram is actually equal to 1 million milligrams. Now, we know that 81 milligram is for one tablet. Then, 1 million milligram is how many tablets? Let's call that x. On cross multiplying, we have that 81x is equal to 1 million. We divide both sides by 81 to get that x is equal to 12,345.67 tablets. Therefore, we can prepare 12,345 tablets of aspirin from 1 kilogram of aspirin. Note that we will have a leftover amount of the drug that is just sufficient to prepare 0.67 of a tablet. Hence, we don't include this amount as it is not up to a complete tablet. Let us proceed to the next question. Question 10. T28 birth control tablets are taken sequentially, 1 tablet per day for 28 days, with a tablet containing the following. Phase 1, 6 tablets each containing 0.05 mg levonorgestrel and 0.03 mg ethinyl estradiol. Phase 2, 5 tablets each containing 0.075 mg levonorgestrel and 0.04 mg ethinyl estradiol. Phase 3, 10 tablets each containing 0.125 mg levonorgestrel and 0.03 mg ethinyl estradiol. Then 7 inert tablets containing no drug. Now the question, how many total milligrams each of levonorgestrel and ethinyl estradiol are taken during the 28-day period? For this question, we simply have to calculate the total amount of levonorgestrel and ethinyl estradiol in the tablets consumed across the 3 phases. For levonorgestrel, in phase 1, 6 tablets were consumed, with each tablet containing 0.05 mg of levonorgestrel. Hence, the total amount of levonorgestrel consumed in phase 1 is 6 times 0.05 mg, which is equal to 0.3 mg. In phase 2, we have 5 tablets each containing 0.075 mg of the drug. Hence, we have 5 times 0.075, which is equal to 0.375 milligrams. In phase 3, we have 10 times 0.125, which is equal to 1.25 milligram. The last 7 tablets consumed contained no drug, so we are not using that in this calculation. The total levonorgestrel consumed is 0.3 milligram plus 0.375 milligram plus 1.25 milligram, which is equal to 1.925 milligram. Now, we repeat the same calculation for ethinyl estradiol. For phase 1, we have 6 times 0.03, which is equal to 0.18 milligram. For phase 2, we have 5 times 0.04, which is equal to 0.2 milligram. For phase 3, we have 10 times 0.03, which is equal to 0.3 milligram. The total is 0.18 plus 0.2 plus 0.3, which is equal to 0.68 milligram. Hence, our final answer is 1.925 milligram of levonorgestrel and 0.68 milligram of ethinyl estradiol. Let us proceed to the next question, question 26. If an intravenous solution containing 123 milligram of a drug substance in each 250 ml bottle is to be administered at the rate of 200 micrograms of drug per minute, how many milliliters of the solution will be given per hour? So basically, the entire preparation is 250 ml and the total amount of the drug present inside that 250 ml is 123 milligram. However, the drug was administered in such a way that only 200 micrograms of the drug was given every minute. Now, we are asked to determine how many milliliters of the solution would be administered in 1 hour if we are given 200 micrograms of the drug every minute. One way to go about this is to determine how many milliliters of the solution actually contains 200 micrograms of the drug. This way, we know that that particular volume is administered every minute. Then, since there are 60 minutes in an hour, we can then multiply that volume by 60 to get the total volume administered in 1 hour. Now, the relationship we know is that 250 ml of the solution contains 123 mg. How many ml of the solution would contain 200 micrograms? We cannot directly cross-multiply here because the units on the right-hand side do not agree. One is in milligrams and the other in micrograms. We can choose to convert milligrams to micrograms or convert micrograms to milligrams. It does not really matter as long as we bring them to the same unit. I will convert 200 micrograms to milligrams, then use it to do this calculation to know the volume of the solution that contains 200 micrograms of the drug. From our reference table or previous knowledge, we know that 1 microgram is equal to 10 raised to the power of minus 6 grams, which is the same thing as 1 all over 1 million gram, or 0.000001 grams. Therefore, 200 micrograms is equal to X. We cross multiply to get that X is equal to 200 times 0.000001, which is equal to 0.0002 grams. Now, let us convert 0.0002 grams to milligrams. We know that 1 milligram is equal to 0.001 gram. Therefore, X milligram is equal to 0.0002 grams. Cross multiply to have that 0.001x is equal to 0.0002. Divide both sides by 0.001 to get that x is equal to 0.2 milligrams. This means that 200 micrograms is the same thing as 0.0002 grams, which is also the same thing as 0.2 milligram. Now, let us calculate the volume. 123 milligram is in 250 ml. Hence, 0.2 milligram is in X ml. Notice how the milligram and ml values are placed on the correct sides. Milligram should stay with milligram, while ml should stay with ml with respect to the side of the equation. When we cross multiply, we have that 123x is equal to 0.2 times 250 ml. Therefore, x is equal to 50 all over 123, which is 0.4065 ml. This means that 200 micrograms of the drug is present in every 0.4065 ml of the solution administered, and this is the volume given every minute. To calculate for an hour, we simply multiply 0.4065 ml by 60 to get 24.39 ml. Now, let us move to the next question, question 46. After this, we would conclude by solving the case in point and call it a day. Conjugated estrogen tablets, Premarin, are available in strengths of 0.3 mg, 0.45 mg, 0.625 mg, 0.9 mg, and 1.25 mg. If patient A took 1 tablet daily of the lowest dose and patient B took 1 tablet daily of the highest dose, what is the difference in the total quantities taken between patients A and B over a period of 30 days? A. 2.85 mg, B. 2850 microgram, C. 2.85 centigram, D. 2.85 decigram. From the question, the highest dose is 1.25 mg, while the lowest dose is 0.3 mg. Since patient A consumed 1 tablet of the lowest dose daily for a period of 30 days, the total drug taken by patient A is 0.3 mg times 30, which is equal to 9 mg. Patient B consumed 1 tablet of the highest dose daily for a period of 30 days too. The total drug taken by patient B is 1.25 mg times 30, which is equal to 37.5 mg. Therefore, the difference between the quantities taken by patient A and patient B is 37.5 mg minus 9 mg, which is equal to 28.5 mg. Careful though, option A is 2.85 mg, not 28.5 mg. Hence, that option is ruled out. Now we may need to convert the other options to milligram to see if any of them will give us 28.5 mg. Let's start with option B, which is 2850 micrograms. 1 microgram is 0.000001 gram. 2850 micrograms is equal to x. Cross multiply to get x is equal to 0.00285 grams. Let's convert these grams to milligrams. 1 milligram is equal to 0.001 gram. X milligrams is equal to 0.00285 milligram. Cross multiply to get that x is equal to 2.85 milligram. Now, 2.85 milligram is not 28.5 milligram. Hence, option B is ruled out. Let us go to option C, which is 2.85 centigram. From previous knowledge or our reference table, 1 centigram is equal to 0.01 grams. Please understand that the statement above is the same thing as saying that 100 centigram is equal to 1 gram, because if you divide both sides by 100, you will have that 1 centigram is equal to 1 all over 100 grams, which is the same thing as 0.01 grams. So, back to our conversion. 1 centigram is equal to 0.01 grams. 2.8 centigram is equal to x. Cross multiply to get that x is equal to 2.85 times 0.01, which is equal to 0.0285 grams. Now, convert these grams to milligrams. 1 milligram is equal to 0.001 grams. Therefore, x milligrams is equal to 0.0285 grams. Cross multiply to get that 0.001x is equal to 0.0285. Divide both sides by 0.001 to get that x is equal to 28.5 milligrams. So yes, option C is definitely the correct answer. No need to test option D, because after converting it to milligrams, you won't get 28.5 milligram.
Who told you that we won't get 28.5 milligram when we convert option D? Are you insinuating or simply underestimating our capacity for calculating or demonstrating the thing that...
Just shut up. In fact, that's your assignment. Solve it and prove me wrong. Sorry about that, guys. We are moving over to the last exercise for this video.
The case in point.
If you are deriving value from this video, please kindly take a second to hit the like and the subscribe button and the bell icon so you'll be notified when we drop more videos like this one. Also tell us what you think about the video in the comments and share with others who may want to see this video. This is one priceless way to support the channel and help us continue to make more original contents like this. Now, let's continue. Case in point. A hospital pharmacist is asked to prepare an intravenous infusion of dopamine. Based on the patient's weight, the pharmacist calculates a dose of 500 micrograms per minute for continuous infusion. The concentration of a premixed dopamine infusion is 400 mg per 250 ml. What is the concentration of the infusion on a microgram per ml basis? How many milligrams of dopamine is the patient to receive in the first hour of treatment? How long will the infusion last?
The case in point.
We will start by extracting the key facts. First, the patient requires 500 micrograms of the drug every minute. We have an already prepared dopamine infusion which contains 400 milligrams in every 250 ml. The first question is to convert 400 milligrams per 250 ml to micrograms per ml. Note that per ml here means 1 ml. In essence, we are asked to state how many micrograms of the drug is in 1 ml of that already existing infusion that we have. We have 400 milligrams in 250 ml. The first step is to determine how many milligrams of the drug is in 1 ml. Then we can convert this amount that is in 1 ml to micrograms. That is all. 400 milligrams is in 250 ml. X milligram is in 1 ml. Cross multiply to get 250x equal to 400. Divide both sides by 250 to get that x is equal to 1.6 milligrams. Now it's time to convert these milligrams to micrograms. Let us first convert milligrams to grams, then grams to micrograms. 1 milligram is 0.001 gram. 1.6 milligrams is x. Cross multiply to get that x is equal to 0.0016 grams. Convert these grams to micrograms. 1 microgram is equal to 0.000001 gram. X micrograms is equal to 0.0016 grams. Cross multiply to get that X is equal to 1600 micrograms per mil. That is the answer for question A.
The case in point.
The next question says that we should calculate how many milligrams of the drug the patient will receive in 1 hour. Remember, the patient requires 500 micrograms of the drug every minute. Since there are 60 minutes in 1 hour, the patient will require 500 micrograms times 60, which is 30,000 micrograms. However, we were asked to supply our answer in milligrams, not micrograms. Now, instead of going through the long process of converting these micrograms to grams first, then converting the grams to milligrams, let us use the direct relationship between micrograms and milligrams. 1000 micrograms is equal to 1 milligram. Hence, 30,000 micrograms is equal to X. Cross multiply to get that 1000X is equal to 30,000. Divide both sides by 1000 to get that X is equal to 30 milligrams. Hence, the answer to the second question is 30 milligrams per hour.
The case in point.
I know that this is the first time I'm introducing the direct relationship between milligrams and micrograms in this video, but be rest assured that if you use the long method, you will still arrive at the same answer. Also note that you can find these direct relationships by looking at some references in the textbook apart from the table I showed previously. You will also get used to these relationships by practicing. Solve as many questions as possible. The third part of the question is asking us how long the infusion will last before it is exhausted. Remember that the total infusion volume available is 250 ml, and this 250 ml contains 400 milligrams of the drug. Hence, once the 400 milligrams of the drug is exhausted, that will be the end. From our previous answer, we calculated that 30 milligrams of the drug is administered per hour. Therefore, the total drug of 400 milligrams will be completely administered in how many hours? Let's call that X. Cross multiply to get that 30X is equal to 400. Divide both sides by 30 to get that X is equal to 13.33 hours. Remember that this is the same thing as 13 hours plus 0.33 hours. Let us convert the other parts to minutes to make our answer cleaner. We have 60 minutes in 1 hour. Hence, we have X minutes in 0.33 hours. Cross multiply to get that X is equal to 19.8, which is approximately 20 minutes. Hence, the entire drug will be exhausted in 13 hours, 20 minutes. That's the answer.
The case in point.
We will also be making videos on other complex courses as well as some entertaining and fun science videos. You can leave your topic or course suggestions in the comment box and we would consider making a video on them. Subscribe to our channel and stay with us on this series as we delve even deeper into the complex and exciting world of pharmaceutical calculations. Until then, keep practicing and never stop learning. That is it for today's video. Don't forget to smash the like and the subscribe buttons to encourage us to continue making more contents like this. Tell us what you think about the video in the comments box and share the video if you think it will be beneficial to your network. Thank you very much and bye.